We are working on a review of biology. This is kind of a simple, basic review, and it's for a Principles of Biology class. We're thinking about the study of matter today. So we're kind of focusing a little bit on chemistry, and we're going to look at different molecules that are common in living systems and things like that. So what is the study of matter? What is that? Everybody say chemistry?
Chemistry.
Okay. Matter is what makes up atoms and molecules. Remember that elements can't be broken down into other substances chemically. In compounds, we have two or more elements in a fixed ratio, as in our favorite chemical H2O, which is what?
Water.
Thank you. Very good. Remember that in a chemical equation, the things that we start with are called reactants. The things that we end with are called what? Products. Usually there will be an arrow, and that means yields, or put this stuff together and it makes that thing, those things on the other side. If we looked at a carbon atom, let's look at this for just a minute. This top number tells us what? What does that one tell us?
How many protons are in it?
How many protons? I'm sorry, I got a little bit ahead of y'all. The top number tells us what now?
Protons.
How many protons? And by the way, in a neutral atom, the protons equal the positive protons equal the negative what? Everybody said electrons?
Electrons.
Hello, thank you. And this bottom number is the
Atomic weight.
Say it again.
Atomic weight.
Atomic weight or mass. And what does this one tell us?
How many protons and neutrons?
Okay, the neutrons added to the proton. So for instance, if I wanted to find out how many neutrons in carbon, I would take this big number and subtract 6. 12 minus 6 makes what?
6.
So it would have 6 neutrons. What would happen if I kind of did a little switcheroo in my periodic chart and I changed it over to carbon 14? What do you call an element that has a different number of neutrons?
Isotope.
It's called an isotope, and in this case 14 minus 6 would make what?
8.
14 minus 6 makes 8, yes. Simply marvelous. Okay, very good. That's good. So let's say, everybody say atomic number.
Atomic number.
And atomic weight.
Atomic weight.
Okay. And one of the other things that I need to make really clear to you is that this top number is the identity of the element. For instance, if you go up to 7, you are no longer carbon. I believe it's nitrogen next. If you go down 1, you're no longer carbon. What is it? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. So if you went down 1, it would be boron, I believe, number 5. So that top number is what tells you the identity of the element. If that changes, you've got a different element. There are about 92 naturally occurring elements, and there are 4 top ones that we think about. What are they? Say them out loud.
Oxygen, carbon, nitrogen, nitrogen.
Oxygen, carbon, hydrogen, and nitrogen. Which one is the most prevalent?
Oxygen.
It is oxygen at 65%. Very good. And these are found in all living cells, is what we learned from this. There are 7 others found in living cells: calcium, phosphorus, potassium, sulfur, sodium, chlorine, and magnesium. And then there are some trace elements which are important for life, but much smaller in number, in percent anyway. Remember that the outer shell electrons are the ones that participate in chemical reactions. And so if we talk about sharing electrons, we say covalent. But if we talk about giving and taking, what do we talk about? That's called ionic. Okay, here's another question. What about if we have uneven sharing? If we have sharing, which is covalent, but yet the electrons are kind of angling toward one side more than the other, what is that called? That's called polar covalent. So what happens when the electrons are shared relatively equally? That's nonpolar covalent. Okay. So by the way, as I'm thinking about it, when you look at a water molecule, let's look at water for just a second as a kind of a bent configuration like this. This end's negative because it has more electrons hanging that direction. These ends are positive, so that's considered to be a polar covalent molecule. And by the way, when water mixes with itself, it flip-flops back and forth, and that's what causes the cohesive nature of water. And when you take water on like a microscope slide, you can actually pick up another microscope slide with it because of a property called adhesion. Remember that these bonds between the hydrogens and oxygens, these are called polar covalent bonds, but it's also possible to have water with itself. It's not just possible, it's what happens. The positive hydrogens are attracted to the negative oxygens, and this creates a phenomenon in water called what? Everybody said hydrogen bonding. Everybody say hydrogen bonding.
Hydrogen bonding.
Okay, that's what produces the cohesive nature of water. And here's another thing, it's kind of flowing in my head, is that if we remove energy from water, it starts getting a lot of empty space in it. And that's what makes something float on the top of the water as it freezes. What is that? Ice, right? Okay, it has lots of empty space. It's less dense than water, so therefore it floats. Another thing that we learned about water is that it can store lots of heat and also release a lot of heat. And so it basically helps stabilize living systems. Let's talk about some other properties of water. Water actually decomposes in a small way into hydrogen ions and hydroxide ions. So if we have a solution and we talk about the pH of it, if there are more hydrogen ions, what do we say about the solution? It's acidic. And if we have more hydroxide or OH, we call what? We say what?
It's more basic.
It's basic or alkaline. Very good. So what would pH 0 to 7-ish be?
Acid.
Acid. And then 7 to 14?
Basic.
Basic. Okay. Also remember that there is a tenfold difference between every number. So let's say that lemon juice was 3 and coffee was 5. That's separated by 2 numbers, right? So how much stronger would lemon juice be than coffee? There's a tenfold difference between 3 and 4. There's another tenfold difference between 4 and 5. So what's 10 times 10?
100.
It'll be a 100-fold difference. So we could say that lemon juice is 100 times stronger than coffee, or we could also say that coffee is 100 times what? Weaker than lemon juice. Does that work?
Mm-hmm.
Okay, lovely. Let's talk about organic compounds. One of the beauties of carbon is that it can bond in 4 directions, and there could be another hydrogen placed here to make methane. But one of the things that makes some organic compounds different are the functional groups. Like a hydroxyl group makes an alcohol, makes something kind of dissolve, it makes a carbon chain, which is basically insoluble with water, makes it dissolve in the water, like ethanol can dissolve in the water, even though it's basically a 2-carbon molecule. Another one that's important in life is the amino group. This NH2 helps to make an amino acid. This is what makes up proteins in the body. Phosphate is another one that is important because it's part of ATP, the energy building molecule or storage molecule. And we also have phosphate in the DNA backbone as well. This last one right here, this CH3, is a methyl group, and this is also an important, methylation is very important in living systems. Remember that a complex sugar can be even very different than granulated particles like we think of when we think of table sugar. It can be wood. Cellulose is wood, and it's a very complex carbohydrate. It can also be starch, like something you find in a potato. Remember that glucose is sugar. It's an energy source for all living cells. Also, if we want to digest a molecule, here's an epiphany that I had. To digest food, you have to drink what?
Water.
At some point, you've got to have some water in your diet. And so basically in chemical reactions, water is used to cut chemicals into smaller units. So we go from polymers down to monomers or smaller units. If your body wants to make something, it involves dehydration. So water has to be removed from the molecules so that they can be joined together. Remember that metabolism is the sum total of all of the chemical reactions in your body. And the way that you and I talk about this is we say, well, he's got a really high metabolism, or she's got a really high metabolism. What would that mean? If somebody had a high metabolism, what would we think about that?
They'd be skinny.
Like they're skinny. It's just like they can eat a whole pizza, stuffed crust pizza, by themselves last night, and they still look like a skinny person today. And those of us who have a little bit of extra weight, anyhow, I'm not trying to say that we're resentful about that. I'm not trying to say that. So maybe here's one of the things that is kind of interesting. Instead of being resentful, I could just build a bigger engine. If I just get more muscles, then I can burn more calories. Is that true? I can also change some of the junk that I put into my body. Maybe that would help. That's right. Instead of playing the blame game, let's change things, man. Let's shake it up. All right, let's talk about monosaccharides and disaccharides. Monosaccharide, glucose is one of your classic monosaccharides. Remember that if you have a sugar like C6H12O6 and it has the same formula, but it looks different, that's called an isomer. And fructose and glucose are basically isomers of each other. They have the same chemical formula, but they look different and so forth. But remember, fructose and glucose together make sucrose, which is our favorite kind of sugar, which is what?
Donuts.
Hello. I was going to say table sugar, but donut sounds great. Hey, by the way, that brings me to a new topic. One of the things that we noticed is that the picture of donuts is a picture of a trans fatty acid, which is considered to be an unhealthy type fatty acid. And that's where if there's a double bond, the hydrogens are on the same side. They're on the opposite side. It's when the hydrogens are on the same side adjacent to a double bond that it actually puts torsion into the fatty acid and makes it healthy. That's a cis fatty acid. Good, very nice. One of the things that I want to talk about before I forget is when we think of a membrane in a cell, it is a lipid bilayer. And so basically there's a water-loving head, which is called hydrophilic, and then there are water-hating tails called hydrophobic. Okay, maybe we shouldn't say water-hating, but water-fearing or something like that. Another thing that's kind of interesting is if you have a protein with a short fat on it, that's considered to be a high-density lipoprotein. Why is it high density? Because the protein takes up more of the percentage of the whole mass of this particle. Whereas a protein with a long fatty acid tail is considered low density because the fat is very light, and this is considered to be a bad cholesterol. And the reason is that if you have proteins that are carrying around long fatty acids, it means that your body's not burning them down very efficiently. That's the issue. We are learning that omega-3 fatty acids are very important for your health. And I also learned the other day that you can get omega-3 fatty acids from eating your green leafy vegetables. I did not know that. Remember that amino acids make up proteins, and long chains of amino acids are called polypeptides. Remember that proteins help form structure. They form enzymes. They aid in transport of oxygen in the blood. Antibodies. Your muscles are made out of protein. They aid in movement. Enzymes are what act on a substrate, and I don't like the word substrate because I don't even know what that means, but it basically just is talking about a chemical. There's a sweet spot on an enzyme, and it just makes it easier for a chemical reaction to happen by lowering the activation energy. Now, it's possible for an enzyme to be blocked. What do you call it when there's inhibition at the active site? Everybody said competitive inhibition.
Competitive inhibition.
Yes, right. We got it, Brother Barnes. And also, what do you call it when there's maybe an alternate site that is engaged that changes the shape of the active site. What is that called?
Non-competitive inhibitor.
That is called non-competitive inhibition. And I probably missed something, but I'm glad you came. Keep coming back. We'll be having more of these reviews as we go along. Holla.